Hello. When I did the first video on a Go Crackme, I realized I didn't look into the stack patterns of Go applications. Therefore, I will do another Go Crackme. This one is called Go 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 Harmfull logic. Harmful logic sounds interesting. It feels like math and dirty tricks. Let's see. Difficulty is rated 2 and quality 4. I don't really know what I'm doing. I guess that means no dirty tricks to annoy me. Let's look at the comments. It was a nice Go Crackme introduction. The Crackme is straightforward, but since it is a Go binary, the disassembly is convoluted. Thanks for the Crackme. Convoluted, never heard of that word. Extremely complex and difficult to follow. Oh, I will see dirty trickery after all. Like the last time, I've already downloaded the Crackme. Because I believe IDA is the best tool in the market, I will use it again. If you get a golang.idc error, please see my first Go Crackme video on how I solved that issue. And like always, I get rid of this graph view. Let's go to main, and the first thing we see is an interesting string. Password blocks. Instead of learning Go, I'm learning internet slang. Please? Really? Blocks means please? So, we see a call to fmt_fprintf. Bloxley asking for a password. The next call is to fmt_fscan. If you know the C language, and you should, you know what this is used for. Because of this layer instruction, I wonder if this var18 is the buffer of the input. Oh, what is this keyword variable? Let's look at the cross references. Let's follow this assignment, as that can be important. Alright, nothing special after all. This is probably part of the Go runtime initialization. A Linux device name /dev/stdin. So let's rename this variable. Since we're on it, let's also rename this stdout related variable. Let's go back to the fmt_fscan. I don't fully understand this go ita ptros file, ptr io reader. We also seem to pass type information here. Let's follow it. In that block, all known Go types are defined, it seems. Not much information here that can help to solve this Crackme. I'll go back. Let's see what else. Runtime string to slice byte. And also a nice string above it. We can as well rename this string. It is probably required to solve this Crackme. var_byte string, I'll add a question mark because I'm not 100% sure yet. Let me copy paste this function name. I've never ever programmed in Go, maybe I can learn something here. This first link looks okay. Just like the name suggests, this is a helper function to deal with a common pattern in the Go language, converting a string to a byte array, or slice as they call it. Let's return to the Crackme in IDA. rtype uint8, that's another name for a byte. A string linked in hexadecimal, I prefer to see the decimal representation here. Now, this transformation of variables on the stack is also interesting. One takeaway from this is that Go does not pass function arguments in registers, but seems to use the stack for this. To be honest, I wonder why. Let's move on. The next call is a call to hex decode. Is this the harmful logic? Are we converting the input of that static string to a byte representation? Where is this jump above instruction going to? A panic? Let's rename the label as such. Let's move on. All these stack operations, they look a bit confusing. Copying, loading into a register and storing it into another stack location? Nah, not that interesting. This label seems to be the loser path. We rename it as such. So if the jump is not taken, then we enter a winner path. Therefore, I introduce a label here. Wait, this should be a local gray colored label. Let's fix that. This is the same. Go ITAP. I will not sing a song this time. And we have the fprintf. This is similar to the fscan we saw before, just printing welcome. Okay, what else can we see here? So before the decision loser winner, we have a runtime mem equal call. It seems to take 3 arguments. Let's see how that is implemented in Go. First, a comparison. I think it's a simple pointer test. The result value seems to be on the stack and not in a register. So odd. Let me rename this variable. And how does this memeq body work? We can see that the rbx and rax are used as input here. This is different from those other API calls. We can confirm that memeq body uses the rax input register to get a pointer to set its result value, and rbx is a count. What else? RSI and RDI are the pointers, so let's rename them as such. Both of them, of course. Let's go back. And one thing I see here, let's review the arguments. We see that this count here is not really a count. It's a pointer to a string. So this renaming, it is not optimal in the case of Go, something to remember. And also here, a little bit more above, similar screw up, let's say. At least I will rename this label and call it Go Compare. The next step is figuring out where Go Compared is being jumped from. So here we have that jump. Let's go a little bit above and see what is going on. So RCX is being compared against some value coming from rax plus 8, which is coming from var20. Now let's look into this slice by to string. Let's look at the arguments here. Of course, they are unnamed. They are just numbers. We didn't really give context to them. This makes it a bit difficult now. So I think this var20 is actually the length of the input, and that rax points to a string object structure. And then rax plus 8 points to the length of that string. So rax itself points to a pointer to the actual bytes. In a real project, we should create a structure here and apply it. Now, this knob instruction here, it makes no sense to me. It's not inside the loop, so what is being optimized here? I don't know. Now, about this RCX here, I'll put a comment here because I'm not a fan of renaming registers. Okay, what is this varco or C0? Let's go look at the Go Compare. So here, varc0 is actually the result. So when we look above, no. I'm giving up on this. This approach is going nowhere with these arguments. Let's look at the string itself, because in theory we have solved the Crackme. Let's just decode this hexadecimal string to an ASCII string. I'll quickly search for some online site to do this. This one looks good enough. Oh wait, I shouldn't have pasted it here. It should have been pasted here. Converted. SolarWinds 123. Funny. I don't want to install Linux to verify this. We do have the source code, so let's look at it instead. Oh wait, what is this? Alright, I should take the one from the comment. Is the author not allowed to edit his description? We have 3 files. Let's look at main.go. So we have the hexadecimal string. We have a decoded len. All the names we saw in IDA are clearly seen in the original source code. Printf and scan. We can actually compare this side by side. Let's close this function window. So the make slice is this make here with the byte. You know, the uint8 from before. The len Where is the len? That's a bit unclear here. Hex decode. IDA really helped us with these names. What else can we see here? R not equal to nil. That's the var A0. The jump above local exit due to slicing error. That's part of the string DSTN. That's more than enough side by side for me. Let's close it. What else? Is there something I can learn more? Let's quickly scroll around. No, 11 minutes for this video. That's more than long enough. In retrospect, I didn't see any harmful logic in this Crackme, and also nothing that I would call convoluted. But I guess I have to thank IDA for that. The difficulty should be rated 1. Thank you for staying with me. I hope you enjoyed it and learned something. See you in another video. Take care. Blog subscribe blogs. Blog subscribe blogs. Blog subscribes blogs. Internet slang. Unbelievable.